For the first two on the left-hand side, what I want you to do is I want you to put these into simplest form. So put 4 over 48 into simplest form and 9 over 135 into simplest form. What I also want you to do is I want you to then take the ones on the right-hand side and convert them from inches to feet. So convert that 192 inches into feet. Convert the 324 inches into feet. So for this first one, what we have to do is we have to find the GCF of 4 and 48. To find the GCF of 4 and 48, we have to figure out what is the GCF. Okay, the GCF in this one is 4. So divide the top by 4, divide the bottom by 4, you get 1 over 12. For the second one, what we need to do is, again, find the GCF. The GCF of the top and the bottom is 9. So you're going to divide the numerator and denominator by 9, which is going to give you 1 over 15. So for the top right one, what you need to do to convert that from inches to feet is actually divide the inches by 12, because that's how many inches are in a foot. And yes, you do get 16 feet. Just like the top right one, again, you need to divide the inches by 12, because there's 12 inches in a foot, and you get 27 feet. What we're going to be starting on today is Chapter 4, Section 6, which is page 172 in your book. It's called Scale Drawings and Scale Models. This is what I was talking about before when I was talking about architecture. A lot of architects do this, okay? A lot of construction people do this as well. What they will do is they will have a building, for instance. Say we have this school building. And what they will do is they will actually draw it out two-dimensionally, which means they just draw it out on a piece of paper, and they will put it into a smaller portion, all right? And then they will give you a factor as to how big it actually is. So a scale drawing, you have 4 vocabulary words. The first one is scale drawing. A scale drawing is a proportional, two-dimensional drawing of an object. Its dimensions are related to the dimensions of the actual object. Okay, so a scale drawing is just a smaller drawing of a big figure or a big thing. Okay. The second one is scale factor. Scale factor is how the dimensions are related. Okay? They are related by a ratio. So there is a ratio between the two. So remember how we were doing triangles. One was smaller than the other. When one was smaller than the other, there was a factor or a ratio between the two that told you exactly how much bigger or how much smaller one of the triangles were. And that's called a scale factor. Your third vocabulary word is scale model. Scale model is a proportional, three-dimensional model of an object. Okay, so this is different than scale drawing. Scale drawing is a two-dimensional drawing of a figure. A scale model, on the other hand, is an actual built three-dimensional figure like a model airplane. Or have you ever seen the three-dimensional puzzles? Those are scale models of the actual bigger object. The last one is scale. The last vocabulary word is scale. And scale is a ratio between two sets of measurements. That's all it is. It's a ratio between two sets of measurements. If you look at example 1 in your books, you will see it says finding a scale factor. So we're going to do this, and we're going to try to find a scale factor. And I'm going to draw the diagram up here. Okay, so there's a box. It has length. I'm just going to put an L for length, and height, H for height. You have a race car and you have a model. So I'm going to put R for race car, M for model. The length for the race car is 132 inches. The model is 11 inches. The height of the actual race car is 66 inches. The model is 5.5 inches. Okay, so they have the actual big race car. That's the first column. The second column is the model that they have built for it. So, to figure out what the scale factor is, all you have to do is set up a proportion. All you have to do is set up a proportion. One side of the proportion is going to be the length, or that top row. The other side of the proportion is going to be the height, or the bottom row. So let's draw our proportion. You have your line, you have your equal sign, you have your other line. What you want to do is you want to put normally the model over top of the actual object. So for our model, we said we're going to put the length on one side and the height on the other. What do you think is going to go in the numerator on the left ratio? What's going to go in the numerator of the left ratio? Yeah, so we're going to put 11 up here. 11 is going to go in the numerator because, again, we're putting the model up top. One side is length, the other side is height. So from here, we have to determine what goes in the denominator. We're going to put the actual length of the race car in the denominator, which is 132. Now we have to look at the right ratio, or the ratio that is on the right-hand side of the equal sign. And remember what I said. The numerator is going to be from the model, and the denominator is going to be from the actual race car. So what is going to go in the numerator here? It is going to be 5.5 because that is the height of the model. And if you look, it's just like what we were doing before with having the numerators be from one figure, the denominators are from another object. Okay, in this case, it's a model and it's the actual race car. So in the denominator is going to be 66 because, again, that's the height of the race car. From here, what we need to do is we need to then separate these. Forget about cross multiplication. We have to separate them. And we actually have to simplify both ratios. So when we simplify both ratios, what we need to do is we need to take 11 over 132. So we're going to take 11 over 132, and we're going to find the GCF. We're going to find the GCF here. What is the GCF of 11 over 132? What is the GCF? The GCF is going to be 11. So what we need to do is we need to now divide the top by 11 and the bottom by 11. So when we do that, we get it to be equal to 1 over 12. Now we have to do the other side, or the height side. So what we're going to do is we're going to take 5.5 over 66. I'm going to tell you what the GCF is. The GCF is actually 5.5. It is 5.5. So we're going to divide our numerator by 5.5 and our denominator by 5.5. That's going to, again, be equal to 1 over 12. So, this is going to give us our scale factor. This is the type of stuff that architects do all the time. They will do this all the time. They will have an actual building, or before they actually build the building, they will draw it out, and they will draw it to scale, and then they will say that the building is going to be 100 times size of this drawing. And everything or every measurement they have on their paper, they will just multiply by 100 to get the actual size of the building. Let's look at example 2. Example 2 is using scale factors to find unknown lengths. So now we're using a combination of 4.5 and 4.4. Example 2 says, a photograph of Reen Magritte's, painting, The Schoolmaster, has dimensions 5.4 centimeters by 4 centimeters. It says that the scale factor is 1 over 15. They want us to find the actual size of the painting. They want us to find the actual size of the painting. Okay? When you see them write 5.4 by 4 centimeters, what this means is that the length of the painting is 5.4 centimeters, and the height of the painting is going to be that 4 centimeters. All right? Remember what we did in the last example. We had length on one side of the proportion, height on the other side of the proportion, right? And then we decided that we were going to then separate them. Well, that's what we're going to do here as well. And remember, the model or the smaller figure is going to be on top. So let's separate them. The length is 5.4 centimeters. So we're going to put that into a fraction. 5.4 centimeters over, do we know what the length of the actual photo is? Do we know what it is? The answer is no, we don't. So what can we put there? What can we put there?
L.
L is absolutely correct. We can put an L, which stands for length. That is also a variable. So it's just like putting X, but in this instance we're putting L. Now, this has to equal our factor, our scale factor. So we're going to put it equal to 1 over 15. Guess what we're going to do now? Cross multiply is exactly correct. So we're going to cross multiply. And we're going to do 5.4 times 15 and L times 1. L times 1. So when we do that, we're going to get L equals 5.4 times 15, which is 81 centimeters. So we have now found the actual length of the painting. It's as simple as that. It's as simple as that. Now we have to figure out what is the height. Think about what our proportion could be for the height. What do you think our proportion could be for the height? 4 is going to be in the numerator for the height. Because remember what I said. The smaller figure, either the model or the smaller photo, not the actual painting or the race car in the last example, that's going to go in the numerator. The actual height of the painting in this case is going to go in the denominator. Do we know the height? Do we know the height? No, we don't. So if we don't know the height, what can we put in the denominator? We can put W to stand for the width. Again, this has to be equal to the scale factor, which they told us the scale factor was 1 over 15. Again, what do you think we're doing from here? Cross multiplying. Boom. Boom. So when we cross multiply, we do W times 1, which is W, equals 4 times 15, which is 60. And don't forget your units. It's centimeters. So, we have now found the length and we have found the width of the painting. Just based off of what information they gave us. They gave us the sizes, the length, and the width of the smaller figure, and they gave us the scale factor. Does anyone have any questions based off of that? Let's move on to example 3 then. Example 3 is measurement application. So now we're going to take these measurements and actually apply them to real life scenarios. On a map of Florida, the distance between Hialeah and Tampa is 10.5 centimeters. So on the actual map, it is 10.5 centimeters from Hialeah to Tampa. Now, in real life, do you think that it's 10 centimeters from Hialeah to Tampa? No. But on maps, what they do is they draw it to scale. Okay, they draw it to scale, and they'll say, well, each centimeter represents so many miles. That's what they'll do. So it says here in the next sentence that the map scale is 3 centimeters. What's that semicolon mean? So that semicolon means that it is a ratio. So the scale is 3 over 128. That's centimeters over kilometers. That's what km stands for. Okay, they want to know what is the actual distance between these two cities. So, we need to set up a proportion here, and it's just like what we did before. It's just like what we did before. If we know how far the distance is between Hialeah and Tampa, we're going to set up a proportion. Boom, boom, boom. Remember what I said. The scale model, or the scale drawing, or whatever we're doing to scale, is going to be in the numerator. What do you think is going in the numerator on the left-hand side? Yes, so we're going to put the 10.5 on the left-hand side because we're going to put the map distance on the top. Now, do we know the actual distance from Hialeah to Tampa? We're looking for the actual distance here. Do we know it? Yes, no, maybe so? No, we don't. So since we don't know it, we're just going to put our variable down there. And I'm just putting d as the variable for distance. That's the only reason I'm putting d. This has to be equal to our scale factor. What is our scale factor? So 3 over 128 is our scale factor. So that's what's going to go on the right-hand side. Again, we must cross multiply and then set up an equation when we cross multiply. Whoop. It will not slide down. Oh, there we go. So when we cross multiply, we get 3d equals, well, 10.5 times 128, which is 1,344. Now what do we have to do? We have to box and bridge, right? So we're going to box, and we're going to bridge, and we're going to divide both sides by what? 3. Divide both sides by 3. You get left with the variable on the left-hand side, and on the right-hand side, you do 1,344 divided by 3, which is 448 kilometers. How do we know that it is kilometers? Why is it not centimeters? So the reason that it is kilometers is because you want to keep the units the same. So in this case, the 128, which is in the denominator, is kilometers, which means that our distance on the bottom on the left-hand side also has to be kilometers, which is what we found. Okay, so this is 448 kilometers, and that is the distance between Hialeah and Tampa. The next thing I want to go into is I want to do this think and discuss. This think and discuss. And what I want to do with it is I want to do number 1 and number 2. Number 1 says, explain how you can tell whether a model with a scale factor of 5/3 is larger or smaller than the original object. So again, the explanation for this is that the scale model is going to be bigger because if you look at the scale factor, the numerator is actually bigger than the denominator. So if the numerator is bigger than the denominator in the scale factor, then your scale model is going to be bigger as well. Number 2 says, describe how to find the scale factor if an antenna is 60 feet long and a scale drawing shows the length as 1 foot. So for this one, all you have to remember is what goes in the numerator, what goes in the denominator. Remember, the scale drawing always goes in the denominator, the scale drawing always goes in the numerator, and the scale, or the actual model, or the actual object goes in the denominator.